Hello everyone, today I'd like to present our recent ICCV 2025 work, Effective Training Data Synthesis for Improving Multimodal Large Language Model Chart Understanding. Chart understanding encompasses multiple tasks, including the chart question answering, chart editing, chart description, and chart code translation. Among these, chart QA serves as a fundamental task for chart understanding. Let me first introduce the chart QA task. Given one question like which initiative have a highest percentage allocation in the chart, the answer is renewable energy. This is a core skill. Read the visuals, link them to meaning, and do reasoning. The previous synthesis chart QA dataset exists two gaps when comparing to real chart. The first gap is limited types. Most synthesis dataset overused just a few types, like line charts. They rarely include novel chart types such as contour or quiver plots. That narrow coverage hurts generalization to real various charts. The second gap is a single plot only. Many datasets only have a single plot, but real papers and dashboards use multi-subplots, so models need cross-panel referee. Multi-subplots bring shared legends, different access, and cross-panel comparisons, exactly the kind of high-level reasoning we want to test. Our dataset is built to fix these gaps head-on. This slide shows a quantitative comparison with other datasets. We include 29 chart tabs and around 250 combined subplots set up, around 10K images, and around 300K QAs. So when comparing with the previous dataset, our ECD shows a lower FID score and the higher average entropy, which demonstrates the realism and diversity of our dataset. And it's not just about numbers, look and feels matters too. Our charts look more like the real ones, the richer styles, annotations, and layouts that narrows the synthetic to real gaps. Here's an overview of our pipeline. It includes 5-step: single plot generation, the combined subplot generation, chart image diversification, chart image filtering, and QA pair generation and filtering. It's modular and scarce build. I will keep each step brief. First, we generate clean, controllable single plots across 29 tabs, varying colors, legends, ticks to ensure stable later composition. Second, for combined subplot generation, we sequentially generate subplots where later plots are informed by the early ones for semantic coherence. Next, for the chart image diversification, we add annotations, the shaded areas, the roomy insets, and other changes to increase the realism. But not everything we generate is perfect, so we need to clean it up. For chart image filtering, we automatically filter out low-quality charts using visual clarity and semantic coherence scores provided by GPT-4o. Owning clear and diverse charts makes the card balancing richness with readability. With the images ready, we create QAs. For the chart QA generation, we create two types of QAs, the descriptive QAs and the reasoning QAs. All these QAs are generated and filtered by GPT-4o. Descriptive QAs target the perception and understanding of specific elements within a chart. For example, what's the title of the left subplot? The reasoning QA focuses on performing calculations and comparisons within a chart, sometimes need across multiple panels. For example, which revenue source shows the largest difference between local media and national media? We include the rationale before generating the final answer. Now, how do we treat our model? We fine-tune pre-trained multimodal large language model on our chart image QA pairs with standard SFT. The structure diversity teaches both the perceptions and the reasoning. To further test the progress, we built our own benchmark. Our ECD bench has more than 1,000 charts, 364 single plots, and 860 multi-subplots, with 2 to 3 tabs per figure. Each image has one descriptive and one reasoning QA, generated with GPT-4o and refined by human. We test the state-of-art multimodal large language models, and the result shows that the O4 Mini reaches the highest performance. We evaluate multiple open-source multimodal large language models across 6 test sets and observe consistent performance gains after fine-tuning on ECD. Additionally, among various training sets, fine-tuning on ECD yields the best overall results. Thanks for listening. If you are interested in our work, you can visit this project page.